Today we're going to start Unit 10, which is triangle congruence, working towards learning how to do proofs. As a review, congruent polygons are identical. That means they have the same shape and the same size. We have these two triangles, ABC, EFG, and we're told in this congruency statement that they are congruent. Okay, and we're going to use this congruency statement to match up congruent parts. And it's very straightforward because the way that the angles are in order here, it matches up with the angles here. So for instance, angle A corresponds to angle E, they are congruent. B corresponds to F, they are congruent. C corresponds to G, those angles are congruent. When it comes to the sides, you want to pair the letters. So side AB is congruent to side EF. Side BC is congruent to side FG, and side AC is congruent to side EG. And we have them listed over here. Keep in mind, if they are congruent, then they have the same measures. Okay, so moving down to our two examples here. If triangle ABM is congruent to triangle DMC, okay, that means angle A is congruent to angle D, angle B is congruent to angle M over here, which has two arcs, and angle C is congruent to angle M on this triangle. So this would have three arcs. When we look at the sides, side AB would be congruent to side DM. We're going to use one tick mark. Side BM is congruent to side MC. This time I'm going to use two tick marks. And then side AM is congruent to side DC. And that gets three tick marks. If you mark your congruent diagrams, then it's very easy to make the connections. Side AM has three tick marks, so does side CD. So AM is congruent to side DC. Since they are congruent, their measures are the same. So since side DC is 7, that means X, which is the length of AM, is also 7. Angle A is congruent with angle D. And angle B is congruent to angle C. I'm sorry, angle B is congruent. Now I'm going to name this with 3 letters because M is the vertex of 2 angles. So it would be congruent to angle CMD. Okay. Moving over to our next diagram, we have a polygon with 5 sides. Okay, so we're going to follow the same concept. Side JK is congruent to side UV. So I'm going to mark that with one tick mark. Side KL is congruent to side VW. I'm going to put 2 tick marks. Side LM, I'm going to put 3 tick marks, is congruent to side WX. Side MN, 4 tick marks, is congruent to side XY, leaving side JN, 1, 2, 3, 4, 5, being congruent to side UY, 1, 2, 3, 4, 5. Now that it's marked, it's very easy to determine which statement is true. KL has 2 tick marks, UV has 1. That's not true. WX has 3 tick marks, JN has 5. That's not true. XY has 4 tick marks, JK has 1. That's not true. JN has 5 tick marks, UY has 5 tick marks. That is true. To find the measure of side UV, UV has 1 tick mark, matches up with JK. JK is 8 meters, so UV is also 8 meters. There's several ways to prove triangles are congruent. If the 3 corresponding sides or 3 pairs of corresponding sides are congruent, they are by side, side, side. If you have a pair of corresponding sides and the included angle of 2 triangles congruent, then they are congruent by side, angle, side. This is the included angle. Okay? If you have 2 pairs of corresponding angles and the included side congruent, then your triangles are congruent by angle, side, angle. Again, this one, this has the included side. That means the side is between the 2 angles. We also have 2 corresponding or a pair of corresponding angles that are congruent and a non-included side. These 2 triangles we can prove are congruent by angle, angle, side. So this side here is non-included. Now this one here is hypotenuse leg. In order to have a hypotenuse, you need to have a right triangle. So if you have a pair of right triangles, the hypotenuse is congruent and one of the legs is congruent, we can prove that the triangles are congruent. Now, there is no congruency theorem for 2 sides and a non-included angle, side-side angle, or you can reverse it, angle, angle, side. You cannot prove that with a regular triangle. Now, if you think you see either of these, side-side angle or angle, side-side, look to see if it is a right triangle. Okay? All right angles are congruent, so this could be side-side angle. If it is a right triangle, look to see if the hypotenuse and a leg are congruent. If they are, it's hypotenuse leg. If it's not, then the 2 triangles cannot be proven congruent. Okay? So, let's look at the following examples. Are they congruent? If yes, what reason can be used to prove it? So notice here I have 2 sides that are congruent, and this is also right triangles. As we know, all right angles equal 90 degrees. So that means that these 2 angles are congruent. And yes, we can prove congruency by side, angle, side. The right angle is between the 2 sides. Okay? If we look at number 5, we have 2 sides and a non-included angle marked congruent. This would be side, side angle. But notice, these are not right triangles. Okay? Therefore, we cannot prove congruency. All right, example 4, we have an angle and we have a side that are marked congruent. Nothing else is marked. However, notice we have intersecting lines. And when we have intersecting lines, we have vertical angles. And if we have vertical angles, they are congruent. So that means this angle is congruent to that angle. So now we have an angle, side, angle. So yes, we can prove congruency with angle, side, angle. Okay? All right, reflexive property is a very, very strong property that you're going to use a lot in your proofs. It's used to show that something is equal or congruent to itself. For example, side BC is congruent to side BC, or the measure of angle A equals the measure of angle A. Now keep in mind, if BC is congruent to itself, the length of BC is equal to the length of BC. Or if the measures of these two angles are the same, the angles themselves are congruent. So anytime you set something equal to itself or congruent to itself, it's the reflexive property. Okay? And then again, here comes bisector. It cuts something into two congruent halves. What we have looked at so far, segments and angles. And keep in mind that midpoints also will split a segment into two congruent halves. So now we're going to walk through some proofs. And you will do your practice on delta math, and this is kind of what you're going to be given. You have a diagram. You're given that segment BD bisects angle ABC, and you're given the markings in the image. So segment BD bisects angle ABC, the reason for that is given. It's right up here. Okay? Now we have a statement. Angle ABD is congruent to angle CBD. And that is true. Why? Because we are applying the definition of angle bisector. Now, when you go on to delta math, it's not going to say definition of angle bisector. It's actually going to write out the definition. So you want to look for the word bisector in conjunction with angle. Going to our next statement, side AB is congruent to side CB. Well, how do we know that's true? It's marked. It's given. So you can use the tick marks or the arc marks. If it's on the original diagram, that's considered given. And now we have BD is congruent to BD. Notice we are setting it congruent to itself. I'm going to go ahead and mark that congruent. And this is your reflexive property. Okay, so now I need to pick the reason why these two are congruent. And I'm going to look at my diagram. If I look at triangle ABD, I have marked side, angle, side. If I look at triangle CBD, I have marked side, angle, side. So the corresponding sides are congruent, corresponding angles are congruent. So this is side, angle, side. Hopefully we're not going to have a fire drill before I finish this. All right, now we're going to do another one. Okay, notice we are just given the picture. So I want to look at what I've been marked. Notice, angle B is marked congruent to angle D. This becomes given. Side AB has the same tick mark as side CD. AB congruent to CD, that's given. Okay. Now I want to look at angle BEA and angle CED. Notice they're formed by intersecting lines. That means they are vertical angles, and vertical angles are congruent. So again, I'm going to mark those angles. So what do I have marked in triangle ABD? Well, if I start at A and go to B, I have side, angle, angle. If I go to CDE, I have side, angle, angle. So my reason for this is side, angle, angle, or angle, angle, side. Either one of those would be correct.